To solve radical equations, we often need to know how to add and subtract radicals. We can only add and subtract like radicals. Like radicals are radicals with the same index and radicand. Index refers to, are we taking the square root, the cube root, so what root are we taking? And radicand refers to the number inside the radical sign. So some examples of like radicals would be the square root of 3 and 5 on the square root of 3, or 6 on the square root of 15 and negative square root of 15, or cube root of 4 and negative 6 cube root of 4. Things that are not like radicals would be something of the form square root of x and square root of y, or 2 square root of 3 and 3 square root of 2, or square root of 3 and cube root of 3. Right, those don't have the same index. To add like radicals, we will simply combine like terms. If you recall something like this, x plus 5x, we can add those because they have common terms. That would be 6x. We add their coefficients. In a similar way, if we have the square root of 3 plus 5 on the square root of 3, we have a total of 6 square roots of 3. So in this example, we'll simplify the sum or difference of radicals. Example A is the square root of 6 plus square root of 6. Those are like radicals. The coefficient of each of those is 1. So 1 square root of 6 plus 1 square root of 6 is 2 square root of 6. Example B, 2 on the square root of 3 plus 3 on the square root of 2. We cannot combine these radicals. And that is because the square root of 3 and square root of 2 are unlike radicals. Example C is square root of 24 plus square root of 54. It appears first glance that these are not like radicals, but we have to simplify the radicals first to see if they can further be combined. Square root of 24 has a perfect square factor of 4. It is 4 times 6. 54 has a perfect square factor of 9, specifically 9 times 6. So when we simplify the radicals, square root of 4 is 2 times the square root of 6, plus the square root of 9 is 3 on the square root of 6. So these are like radicals. We can combine them to get 5 square root of 6. Example D is 4 on the square root of 27 minus 2 on the square root of 75 minus the square root of 3. Again, we need to look for factors that are perfect squares that we can extract from these roots. 4 times the square root of 27, we can look at that as the square root of 9 times 3, minus 2 on the square root of 75, we can write as 25 times 3, and then minus square root of 3. So keep in mind we're looking for a perfect square that divides the radicand. The square root of 9 simplifies to be 3, so we have 4 times 3 on the square root of 3, minus 2 times the square root of 25 is 5 times the square root of 3, minus the square root of 3. Multiplying the coefficients gives us 12 square root of 3 minus 10 square root of 3 minus 1 square root of 3. 12 minus 10 is 2, and 2 minus 1 is 1, so this simplifies to be 1 square root of 3, or simply square root of 3.